I first define the object of this program, which is to develop a subroutine for reading metrics. In the main program, we will test it. A Fortran program begins with the 7th column. I say it's a matrix 2D, and a program must have a definite length. Program. Implicit none, and then the declaration statements begin. It is recommended to have separate sections for the declarations, variable declarations. Let's save it so that we can see the highlighted part. Okay. In the bin directory, matrix 2d.font. Okay. So declarations. Here we have to explicitly define. I define integers I, J, K, and I define a real matrix B 2 by 2. I define a matrix C 3 by 3. And let's assign some values for the time being. This is the initialization to set values. I initialize with the data statement, data B matrix 1, 2, 3, 4, and let's print it for the time being. And I write here do I varies from 1 to 2, and our objective is to print it. Okay, so I write the statement right asterisk comma asterisk, and here I write here a ij, and they varies from 1 to 2, and do. So I have assigned some values to column the matrix B, and I'm just printing it. Run it. This is in B directory, and here we have the 77, then again G77, and indirect. Okay, let's compile G77 matrix 2D dot or minus 4 matrix 2D dot ex. Okay, first step is accomplished. Compiled correctly. Nothing seems to be inconsistent with Fortran syntax. So we have 1, 2, 3, 4. So we provided the values in one row, and 4 values have been printed. So we can do that in this way. So we found that the first two values have been settled in the first column, and the next values are settled in the second column, right? So this is the structure. This is the structure. for writing. So let me let me change this one to another thing. I define here a integer like the IU and AU, two integers, and I define a character variable that can store 20 values. I say this will be I file and this will be the O file. Two character variables that can store two names. And my intention is to provide here the names of files. So here I define first O file. This is for output file, and I define matrix 2D dot out. Dot after dot, it is the extension of the file. So it's a generic extension. I define the output AU value as say 60. 60 a number. It is just like roll number. I will identify in my print statements this file with the roll number, with the assigned number. So now I write another statement here. Open. I write unit equal to IU, means AU, and then I write the keyword file. Let's say it is O file, and I write the status. And status for the time being, I write here unknown. So key attributes of file. I have defined a file name, O file. I defined an integer JU that I used in the open statement. And in the open statement, we have unit defined, file name defined, and status defined, right? So we will see later on what are the options. Now, with this write statement, I write another write statement. I write a write. With the first asterisk, I write AU, and the second asterisk as such, which means now a connection is going to be made between JU, write statement, JU, and JU is in open, and in open there is a file name, matrix 2D dot out. And I write exactly the same statement which is above, Bij, and J varies from 1 to 2. From 1 to 2. So that you can clearly observe the differences. So O file, JU, open statement, and then the write statement, right? So let's run it and see what's going to happen from this program. Matrix 2D.for should be compiled. It is rightfully compiled, and then the answer matrix 2D. Okay. In the command window, something is there, but where is JU unit? JU is in the program, and let's open the directory. Is there something with the name matrix 2D? There is matrix 2D file 20 bytes, and it is the output file dot out extension dot txt. Let's open this file, and it contains the answers. So the answers can be exported to another file. The same write statement, but you have to provide the file specification, right? You have to open a file and you have to define its unit, its status. So that is writing the data on a file. So slightly modified print statement and with the logical things. Now this is the right statement, writing the matrix. So can we use this one in a subroutine, because we would like to read matrices uh, on files, and they may have different sizes for a journal n size. So can we do that? So we do that in our usual style. So I copy this structure from here, Control X, and at first write the subroutine below this program, and when it is matured and we all agree, then we will shift it to our library. So I write here a subroutine read matrix, read M matrix A of size n by n. For the time being, I'm saying for a square matrix, and there should be the unit specification. I say I unit, and then the part of program I copied is this one. There are variables that need to be defined. Define integer n u. I have to define a matrix A of size n by n. It is generalization, and we need some integers to run the loops I, j, k. This part is the same, right? So I can modify it. I should modify it. Do I varies from 1 to n for a general matrix A. So this should be A. So, it should print on the unit IU unit in the Fortran default format. By the way, you can provide here a format. We did that last time. Aij, and j must vary from 1 to n. Do that's it. And finally, the subroutine ends with the word return, and the end subroutine read matrix. Let's use it. We have generalized the structure integer iu, right? Well, I was defined ij. J has been used here. So this subroutine is going to read the unit of file, right? So file name is in the main program, and unit is given to the subroutine. Let's see whether it works or not. So in the main program, we have the matrix, its data, the name of the output file, the unit specification, and the open statement. And now here I'm going to give a call to the subroutine, call read matrix B size 2 by 2 and from unit AU, right? Okay. Now let's compile it. Compile the program. Okay, this is fine. And now run it. So here, nothing has been printed, but we can see the results. It says that the file has been updated, modified by another program. So it is same. If you're not happy, I can convince you. I say delete matrix 2d dot out. So now if you check the folder, there is no matrix2d.out file. There is one application file, there is for file, there is no other file. And now if I run the program, there is nothing. Okay, I can do it from here. Type matrix2d.out. The answer is there. There is C33. So let's define data. C, 3 zeros, then 1, 2, 3, 4, 5, -6. So there are 3 zeros and then 1 to 6 numbers. So 9 elements. And this is matrix C. And I call read matrix C 3 by 3 and on unit 6. Unit AU. And I call read matrix C3 unit 6. Save the program and see what are the outputs. We have two matrices defined. One is 2 by 2, the other is 3 by 3. And we are writing it their outputs, the data in the file. Compile the program and run it. So with the second command, with the unit 6, it means printing on the console, printing on console. And if I open the file, matrix2d, yes, this is output file. And behold, 1324, and the C matrix has also been printed with the help of subroutine. So we have developed a subroutine for writing the matrix. So on similar lines, we can develop a subroutine to read the data, I have written the data, but I have named it as read. So its name should be write M. Be consistent with the English language, even though there is no problem with the in Fortran, but it should be consistent with the English language. Otherwise, it will create a great confusion for you. At the beginning, my intention was to develop a subroutine for reading the data, but I developed a subroutine for writing the data. So it's time to shift subroutine for writing the data to our library. CF library. Let's bring it closer to our programs just by selection and dragging. CF library. Well, this is subroutine to write M, and okay, this finally it should be write M. Save the file from here and save the file from here. And we have to remind ourselves that we have to now compile the program with the library. C library dot write matrix 2d dot out. Okay, so it was not saved, and the library file subroutine write integer a, spelling consistency write m, and that's it. Let's run it. Let's compile it once again. Yeah, compile with the library. Okay, something very strange. Let's try to explore the statement. Write m matrix a and iu in function maximum of matrix. And function and subroutine write m. Subroutine write m. Write m. Write m. Write on unit iu. Okay. File name was defined. Write m. 108. CF library 108. Yes, this is in sixth column. This is in sixth column. So the inconsistency came from here. So it identified the error that it was just after the matrix mat at the beginning. So then when something is wrong, then you have to patiently correct it. That's fine. And we can see now the success of our program. So here the elements of C are printed. We use in the main program the unit number 6, which says to print on the console, and for writing on JU unit we have the output. Notepad++ says that this program has just been modified, so you can see the output. On similar lines, as you have observed, while printing we have just provided the unit number, file name, and its third attribute, the status. The status for a file for which you would like to read should be unknown or it's old, because you can only read data if it is already written on a file. For writing, you can say it can be new if you are creating it for the first time, but if you are uh, changing that in output file again and again by running the program again, so you can say unknown. It means if it is not there, it will create, and if it is already there, it will update that status.